Hello everyone. In this lecture, I'm going to discuss the D flip-flop. We can construct the D flip-flop with the help of SR flip-flop. So let's quickly recall the SR flip-flop, how SR flip-flop works. Okay, so if you look at the truth table of SR, when the clock is low, S and R becomes don't care, and it will preserve the previously generated state, that is Qn. When clock is high and both S and R pin are low, then it will preserve the previous state, that is Qn. If clock is high and R is high but S is low, it will generate 0. And if clock is high, S is high and R is low, it will generate 1. And this last combination is invalid because it will start generating Qn plus 1 or Qn plus 1 bar, same value. So this is not allowed. Now, if we talk about the D flip-flop also known as data flip-flop. So whatever we give, we want the same data to be preserved or generated as Qn plus 1. So in this case, if you look at whenever the SR is generating something, there are two scenarios. So if you focus on this and these two scenarios, where S and R are having different values and it is generating the output either 0 or 1. So if we draw the block diagram of SR flip-flop, it will look like this. This is the SR flip-flop. Now in this, when these combination we do not want that S and R both will get same value like this. And if you want to make it off or preserve the memory element, we can just do that by making this clock low. So what we can do in that case, we can join. So let's say if I use a NOT gate here, so I'm connecting this with the help of a NOT gate like this. So there is a NOT gate, let's say. And with the help of this NOT gate, I have joined this pin. So let's consider this is a D pin. This is D flip-flop. So saying this is D. And it is connected after negating this input to this. Now in that case, when we pass 0, this R will become 1. When we pass 1, it will become 0. And if you want to store the previously generated state, this clock we can make low, right? So in this case, if we draw the truth table for this, let's draw it. So there are clock and D as input, which will decide the outcome. So let's say clock is 0. If clock is 0, this will become don't care and the previously generated state will be preserved, right? But in case clock is high, so if clock is high here, and if D is 0, so if D is 0, clock is high, this is 0, in that case this will become 1. So if it is the scenario 0 1, in case of 0 1, it will generate 0, right, as per the truth table of SR. Let's consider the another case when the D is high and clock is also high. So when this is high, in that case, let's say this is high, then it will be low. So this is the scenario, the third scenario, 1 0. In 1 0, it will generate 1. So this will be the truth table of D flip-flop, and notice that once we are passing here 0 as D, we are getting 0, and if we are passing 1, we are getting 1. So this is the data flip-flop which just generate the data which has been passed, right? So by utilizing this truth table, we can draw the characteristics table and excitation table. So let's draw the, okay. So we are already aware about in characteristic table, we will have two parameter as input. So let's say Qn, we will have D, and we will predict the Qn plus 1, right? In an excitation table, we will take Qn into the consideration along with Qn plus 1, and we try to predict the value of D. So in case these two parameters are there, there will be four possible combinations. So 0, 0, 0, 1, 1, 0, and 1, 1. Now when Qn is 1 and Qn is 0 and D is 0. So when Qn is 0 and D is 0, so if D is 0, it doesn't depend on Qn. The Qn plus 1 will be 0 only. Similarly, when D is 1, it doesn't depend on the previous generated state or output, that is 0. So it will just give you 1. Similarly, here you will get 0 and here we will get 1. So it is 0, 1, 0, right? Now let's come to the excitation table. Again, there will be four combinations. So 0, 0, 0, 1, 1, 0, and 1, 1. Now when Qn is 0 and Qn plus 1 is 0, if Qn plus 1 is 0, D must be 0, because it will be equivalent to 0. So you can say 0, 0 and D is 0, right? In this case. Now when Qn is 0 and Qn plus 1 is 1, if this is 1, the D must be 1. As simple as that, right? So if you consider here 0, 1, it is 1 only. In case of 0, it will be 0. So if you consider 1, 0 case, this is 1 and this is 0, and Qn plus 1 was 0. So this is that case. And last case, 1, 1 will give you 1. So this is 1. So this is the excitation table and characteristic table of D flip-flop. This is sufficient for the lecture, so I'm closing it. Thank you everyone for connecting.